All right, class, this is lesson 2.1, types of matter. Take a look at what we have here. It says classify each of the following with the combination of terms listed below. So either it's a pure substance or it's a mixture. If it's a pure substance, it's either an element or a compound, or if it's a mixture, it's homogeneous or heterogeneous. Take a look at my flow chart. This is really going to help us here. So the first thing I need to do is to take a look and see no matter what the matter is, can it be separated by physical means? If it's a yes, then what we have is a mixture. Okay, if it can be separated like salt plus sand in a big jar, if I can literally take each one and separate it into a salt crystal and sand and separate them, then it is, of course, a physical mixing of things, and that's a mixture. Now, is it mixed evenly? If you answer yes, then it's a homogeneous mixture. That means, do you see a difference in the consistency? If you don't see a difference in the consistency, then it's a homogeneous mixture, which we also call a solution. If you do see a difference, like soil or wood or milk, milk actually is one that doesn't look like there's a difference, but because there's oils mixed with water, that means that it's a heterogeneous mixture. Okay, so if it can't be separated by physical means, such as if I have a chunk of gold or another metal that we know to be like an element, not an alloy, then of course, then what we have is a pure substance. Does it consist of more than one element? If the answer is yes, then it's a compound, such as water, sodium chloride, carbon dioxide, sodium bromate. You will often see that there is more than one thing. Like in the names, sodium chloride has like a first name and a second name, first and last name, which means that it's a compound. Other things like gold, sodium, sulfur, oxygen, those are just without first and last names, which means it's not a compound. Let's go back and take a look at a couple of these. I'm going to let you do a bunch of these, but here's another thing. If you see more than one capital letter, so I see an H here and a capital C, that means there's more than one capital letter. That means I have two things, which is what makes this into be a compound. Okay, so that is a compound because I have more than one capital letter in its formula. Just like when I say sugar, and you see the C, the H, and the O, more than one thing means that I have a compound here. Okay, KBR, again, I have more than one thing, which means I have a compound. Now take a look at soil. Soil does not have a formula, and soil can be separated into multiple things, right? So this is actually a mixture, and in this case here, because it's not mixed evenly, this would be a heterogeneous mixture. Okay? So if you see something that has more than one capital letter in the formula or more than one name, as in iron oxide, then you can also be sure that this is also a compound, a pure substance, but it's a compound. See what you can do with this. I'm going to let you figure. If you'd like to see the answers to this, I have the answer key in class, and I'd be happy to show it to you. So there's our classification of matter flow chart to help give you some help. Matter that is composed of two or more different elements chemically combined, this is completely from the definition. And of course, that's what a compound is. I'm not going to answer all of these for you. I'm going to skip every other one. A compound differs from a mixture, and that compound always has the same a homogeneous composition. And that's because it always has the same number of atoms of each element, such as water with 2 hydrogens and 1 oxygen, carbon dioxide with 1 carbon and 2 oxygens, and that gives it a homogeneous composition. Heterogeneous, I'm skipping every other one here, so let's keep going. Which must be a mixture of substances, a solid, a gas, a liquid, or a solution. This right here is another term for a homogeneous mixture. So that would be my answer. Which substance can be decomposed by chemical means? Well, it can't be this, can't be this, can't be this, because those are all elements. So the only thing that's not an element is ammonia. How would you know if oxygen, silicon, and phosphorus are elements? You would look for the names on table S. Which substance, oh, we're moving on here. Two substances, A and Z, are to be identified. Substance A cannot be broken down by chemical means. Substance Z can be broken down by chemical change. What can be concluded about these substances? Both substances are elements. Both substances are compounds. Substance A is an element, and substance Z is a compound, or substance A is a compound, substance Z. So A cannot be broken down, so that means that A is an element. B can be broken down by chemical means, so that means that, Z is a compound. So your answer is, of course, number 3. Two different samples decomposes when heated. Only one of the samples is soluble in water. Based on this information, these two samples are both the same element. Nope, because two different samples decompose. Okay, so both the same compound, two different elements, or two different compounds. I would say it's two different compounds because both of them decompose, which only compounds can do. But one of them is soluble in water. Soluble means dissolved, can dissolve in water. Okay, that's what soluble means. When you dissolve something in water, that's how you get a solution, or one way you can get a solution. So based on this information, these two samples are two different compounds. Table below shows the mass and volume data for the samples of substances at the same temperatures. So which two samples would consist to be the same substance? Well, this is mass versus volume, and we know that density equals mass divided by volume. So any of these that have the same density would be the same substance that we would surmise. That's what we would guess. So 30 divided by 60 would be 0.5 for density. 40 divided by 50 would be 0.8. 45 divided by 90 would be 0.5, and 90 divided by 120 would be 0.75. I just got those by taking whatever this number is divided by this number. So it looks like substance A and C, like that, are the same substance. Okay, I'm going to let you go with that. Keep working on these. I hope that helped. I'll talk to you later.